Hello class, good day. Welcome to our subject statics of rigid bodies. Today we will talk about forces in space or forces in three-dimensional surfaces. Lecture number 4. Let's start. Essentially, forces in space requires for you to deal with forces in the three-dimensional field. Okay, so we will not talk about in 2D spaces, but 2D planes, but now in 3D diagrams. And because this is the reality. In reality, you have fourth dimension, you have fifth dimension. But for the complication of this study and for us to grasp the ideal part of statics, we will talk about forces in space or in 3D space. And same thing with your two-dimensional plane surfaces. The resultant can be determined using parallelogram law or the triangle law. Rectangular components can also be used to get the resultant. The resultant of concurrent forces acting on a particular space will act at the same particle. Only the magnitude and direction are to be determined. So in this case, we have three forces in a three-dimensional phase. The resultant force is a single force that is to be determined. What is to be determined? The magnitude and direction. Okay? In this illustration, the magnitude and direction of all forces are given. So let's look on this. That's why we will need to talk about the force polygon. Okay? So before we only talk about the resultant force, but in this case, we are now dealing a polygon or a surface of the force. The resultant force which can be drawn from tail of the first force to the head of the last force. The magnitude and direction of the resultant can be computed using successive use of the triangle law and also by the parallelogram law. The sine and cosine laws are hard to implement because usually the given angles are absolute. Okay? So in respect with different planes. In order for us to determine the rectangular components of the force, in this case, force F, along this plane, let me draw, or let me highlight. Along this plane, this is a three-dimensional plane. Okay? So it behaves like the hypotenuse, right? So it has an angle of inclination of theta z along the z-axis and an inclination of theta y from the y-axis. So, from the plane xy or the surface of the, what you call this, the quadrant or the plane of xy, it is inclined by theta xy. And from theta z, it was inclined by theta z from the z-axis. Okay? So we need to identify the magnitude and the two angles using the cosine. Okay, actually this will be the cosine rule or the directional cosines. So straightforward, no? F sine theta z for the fxy component and f cosine theta z for the fz component. The rectangular components of a force. So as we can see here, this is the force polygon. Okay. The xy component is inclined by theta xy and again inclined by theta z from the z-axis. So as we can see here, theta or the force xy is in the same plane as your z-axis, right? So I hope you can visualize, right, in this plane, the one I'm pointing out. Okay, this one. If you will have questions, guys, you may comment down below in this video and or message me in Facebook, and I'll be happy to answer your questions. Okay. Essentially, these are all your cosines. So in order for you to determine the Fy component, you just need to decompose the Fxy, which is essentially your F sine theta z, like in this case. Okay. In order for you to get the Y component, cosine theta xy multiplied by the Fxy, where we will identify the sine theta z component of the F. Okay. So in summary or in vector form, we can simply get it by this. Fxi plus fyj and fjk hat. And the resultant is simply your Pythagorean theorem, fx squared plus fy squared plus fz squared, and getting its square root. Okay? So as I said earlier, given the magnitude and three absolute angles, we can simply use the directional cosine or the direction cosines, where fx is f cosine theta x, fy is f cosine theta y, and fz is f cosine theta z. Okay? So let's look on this example. A force of 500 Newton forms angle of 60, 45, and 120 degrees respectively with the x, y, and z axes. We are to find the components of fx, fy, and fz of the force. We are to find also the vector representation of the force. Now, how will we identify that? By simply using the directional cosines. So, solving for each component of the force along the x, y, and the z axis by simply substituting 500 multiplied by the cosine. The degree will be determined from the directional cosine. So in this case, for the x-axis, 60 degrees, for the y-axis, 45 degrees, and for the z-axis, 120 degrees. So from this, we can simply get that resulting vector, force vector. And for you to get the magnitude, simply get the Pythagorean theorem of this. So 250 squared plus 354 squared minus 254 squared, and getting its square root. Okay. Now let's talk again, or let's talk about more on the direction cosines. So the unit vector. What is the unit vector? Essentially, class, if you get the squared of each directional cosine, in this case cosine theta x squared plus cosine squared theta y plus cosine squared theta z will give you 1. The force vector is equal to the product of the magnitude of the force vector and the unit vector. So the unit vector is this, okay? Take note of this, wherein its magnitude is equivalent to 1. Let's look. So the direction cosines, as we said earlier, is simply the following. The fx component, or the cosine theta x, is simply the fx divided by the magnitude of the total force, arc cosine. And the same thing that you will do for the theta y and theta z. For the magnitude, you simply get the resultant, or the, what do you call this? Hypotenuse of the force polygon. So given this, a force that has the components 20, negative 30, and 60, determine its magnitude in the angles of theta x, theta y, and theta z. So by just simply getting the magnitude, getting the squared of each one, and getting its square root. Now, how about its direction? By simply dividing the x component divided by 70 and getting its arc cosine. Okay, so like in this case, 20 divided by 70 and arc cosine. And for y-axis, or for the theta y, 70 divided by negative 30. Take note of the magnitude, negative 30. This doesn't mean that the force is negative. It just means that it has a different direction. Okay? So it is inclined by a 115 degrees from the y-axis. And finally, for theta z, arc cosine of 60 divided by 70. Basic? Very basic. Now, how about if given the magnitude and 2 points where forces, or where the force passes? You can simply get the following. So by using the distance formula. Okay? So it's simply the following. Class, you don't need to memorize the following. You just need to remember each concept. So again, everything that we discuss is very idealistic and will be essential when you step on the higher courses on civil engineering. Okay, statics, kinematics, dynamics, and so on and so forth. Okay. So for the rectangular components of a force, so from the distance formula, change of the x and y and change in z. Now, we are to determine the vector representation of the given force. So we have here a following, or a three-dimensional plane where we will get the following points. So the x is simply 1.2 meters, the y is simply 1.5 meters, and the z with the height of 2.4 meters. So with point O visualizing this one, so as we can see here, it is not elevated along the z-axis. That's why it is 0 there. It is inclined by, has an increment of 1.2 meters from the x. That's it. And from the y-axis, it's simply on the height of 1.5 meters here. Okay? So for how about letter E? So letter E is not inclined or incremented from the x-axis. That's why it's 0. So it is actually in the plane ZY. Okay? So from a height of 2.4 meters along the z-axis, this one, and a length of 1.5 meters from the y, or from the z-axis and the z and x-axis, that is here. As you can see here. Let me do if you, for you to easily look. So in this case, again, E is not inclined along the x or along the z plane. So kumbaga nakalapat siya. It is sitting on this plane, on zy plane. And from 2.4 meters, so as we can see here, it is inclined or incremented here in this level. So this one, 2.4 meters. And 1.5 meters for y, this one. Okay. Oh, sorry about that. I don't have a ruler in writing this one. Okay. So by simply getting the resultant, or the, what do you call this, the hypotenuse, by simply using the Pythagorean theorem, we can simply solve the hypotenuse to be 2.12 meters. Now, by simply getting the directional cosines, by getting arc cosine for each axis, that will be this, right? So the force vector component is simply negative, magnitude pala yung hinahanap. Sorry about that. So we are getting the magnitude. So that will be, the hypotenuse will be the, so that will be the length of the x divided by the total length of the magnitude multiplied by the x component of the force. Okay, the total magnitude of the force, okay? 1.6 kilonewton. So in this case, take note again, you need to have the y component, the z component, divided by the total distance, the resultant that we have computed a while ago, multiplied by the, what's this? The total magnitude of the force. So, you will get each vector component. So, in order for you, once you get the resultant of this one, in order for you to get the total magnitude, it will bring out 1.6 kilonewton also. Okay, and you can also use the other formulas in order for you to identify the directional cosines. Okay? So, a book problem, a frame ABC supported in part by cable DBE, which passes through a frictionless ring at B. Knowing that the tension in the cable is 385 Newton, determine the components of the force exerted by the cable on support D. So, looking at this, we have a 0.0, or the origin, in this part, okay? And this one is your point, what's this? This is the point E, okay? You have the point E rather, sorry about this. So this one is your point E. So getting the distance for each x and y and then z, you will simply get the following. So how did you get 770, sir? It's simply the resultant of this one. Oh, sorry. Hypotenuse again. Okay? using Pythagorean theorem. So again, solving for each component, for x, for the I hat, for the j hat, and then for the k hat, the force vector component of each one is simply the magnitude multiplied by the distance of the x component divided by the total distance. So this one. So that will be 480 divided by 770 multiplied by the x component. That will be or the total magnitude, that is 385 Newton. Okay. So I guess you can also look on this problem. We have many problems, right? So you may pause this video if you want to review. Now how about addition of concurrent forces in space? So again, in reality, you can simply add forces. The resultant of two or more forces will be determined by summing their rectangular components. The graphical and trigonometric methods are generally not practical because tedious. How about if you have four forces in a three-dimensional space? That is very tedious, okay, and very hard to solve. So what we will do is simply, just like what did you do on the previous quizzes in the previous lecture, you simply add per component, okay? Simply add all of the x component, all the y component, and all the z component. So for the magnitude, you can simply get the hypotenuse, and for the direction, directional cosines. The same thing. Now, how about in equilibrium of particle in space? So, again, class, the resultant of forces, if it is in equilibrium, the resultant is always 0. Take note of that. So, the summary of the forces along the x, y, and z axis is simply 0. And we will maximize this because we are dealing with statics. The above equations represent the necessary and sufficient conditions for the equilibrium of a particle in space. So let's look on this. We have your problem. A 200 kilogram cylinder is hung by means of two cables, AB and AC, which are attached to the top of a vertical wall. Since this cylinder is in static equilibrium, we know that the force or the resultant is simply 0. First, you need to identify the force body diagram with this one, okay? The point A was chosen as free body. This point is subjected to 4 forces, 3 of which are unknown magnitude. Now we are to identify it by simply getting the following. So the weight is simply mg applied to the j-axis, okay? So I is the horizontal, j is the vertical axis, and k is your into or out to the page axis. So in this case, simply solving for the weight, that will be 200 multiplied by the gravity or the constant due to acceleration, 9.81. Next, we are to identify the unit vector component of along AB. Okay, so in order for you to get the direction, okay? So the summary of the distance AB is simply the following. So we have the components x, y, and then the z component. So that will be the using Pythagorean theorem, again getting the hypotenuse, we can get 12.82. Now, dividing everything or the force vector divided by its magnitude, distance magnitude will give you the unit vector. Okay, so this is the direction. Again, take note, class, that this unit vector has a magnitude of 1. Okay, 1. So if you get this resultant of this, or take resultant ako ng hypotenuse of this 1, this will give you the unit vector or unit value of 1. Okay? Now, how about for the AC? So same thing, getting the magnitude using the Pythagorean theorem, dividing the vector form of AC, dividing by its magnitude here, will give you the unit vector. So again, this unit vector getting the hypotenuse will give you a value of 1. So why do we need to identify the unit vector, class? We need that for you to identify the final force. Okay? So summing up everything, since we all know that this will give us 0 value, so TAB plus TAC plus P plus the W or the weight. So this one, and joining all components of I and all components of J and all components of K will give us the following. The summary of forces along the x-axis and the y-axis and the z-axis are all 0. Okay? So simply get this. You need to get the, as I said earlier, you need to get the unit vector in order for you to get the total magnitude or the force along that component. Okay, so imagine this one, class. This one, a while ago, has a multiplier of I hat, right? So since this is in equilibrium, this is equated to 0, you can simply omit I. So dividing both sides by I. So that's the value of the unit vector. Okay. Now we all know that when we find the value of this one, or this equation will give you the force or the summary of forces along the x-axis. That is equated to 0. So in order for that to happen, you need to identify the following forces. Again, the unit vector is used for you to identify the total magnitude of the force. So in this case, TAB, TAC, and P. But in this case, in the first equation, we have only one equation but three unknowns, TAB, TAC. Two unknowns. We identified P already from the weight. Okay? Not yet, not yet. We haven't identified P. So we have identified the weight only, this one. So again, TAB in equation 2, and then in equation 3. So we have three equations with three unknowns. With three unknowns, A, B, A, C, and P. So we can easily substitute everything. So using your scientific calculator, you may use shift solve, will give us the following. Solving simultaneously. Tada! Okay. So, example 15, the 100 kilogram cylinder is suspended from the ceiling by cables B, C, and D. What are the tensions in cables AB, AC, and AD? So, again, we only have the identify the weight in this case. So, 100 kilogram multiplied by 9.81. So, summary of forces, TAB, TAC plus TAD minus TA 981 J hat along the y-axis, this one, will give you 0. So, again, for you to identify this, you need to identify the unit vectors again. So, giving us the following. So, again, this is very straightforward. Mukha lang siyang nakakalito kasi ang daming letters, right? But this is just the same as our solution a while ago. So, distance formula and getting its magnitude here, or the result hypotenuse from the Pythagorean theorem, and then dividing the force vector with its magnitude is simply the unit vector. Okay? So, for each one, you need to multiply in order for you to get the unit vector, and summing up everything along the I hat, and in combining the J hat and combining the K hat, this should be all equal to 0 since this is in equilibrium. Okay? Now, you will be left with the following. Again, three equations with three unknowns, TAB, TAC, and TAD. So, solving simultaneously will give you the following. So, that will be it, class. This is a lecture for forces in spaces and equilibrium of forces in three-dimensional surfaces. Thank you all, and God bless you all.